Derivative explained. Math, finance, chemistry, and linguistics with real-life examples. The word derivative has different meanings across various subjects. From mathematics to finance, from linguistics to chemistry, derivatives are everywhere. This video explains each meaning with real-life examples for easy understanding. Understanding derivatives is essential because they help us analyze changes, form new words, create useful chemicals, and manage financial risks. Derivative in mathematics. A derivative measures how a function changes as its input changes. It represents the rate at which something is increasing or decreasing. The concept is widely used in calculus, physics, economics, and engineering to understand motion, optimization, and changes over time. Basic formula. If f x f x is a function, its derivative is written as f x f x, or d dx f x frac d dx f x. This shows how small changes in x affect f x f x. Example: speed and acceleration. A car moving at 60 km/h increases speed to 80 km/h in 5 seconds. The rate at which speed changes is acceleration, which is the derivative of velocity with respect to time. This principle applies in physics when studying motion and forces. Example: business profits. A business owner calculates how profit changes with increasing sales. Taking the derivative of the profit function helps determine whether producing more items increases or decreases profits. This is widely used in economics for marginal cost and revenue analysis. Graphing a function with a tangent line at a point visually demonstrates how derivatives show change. Second-order derivatives, which measure the rate of change of the first derivative, help analyze concavity and points of inflection. Engineering, used in designing bridges, airplanes, and electrical circuits. Medicine helps analyze the rate of disease spread and effectiveness of drugs. Machine learning, optimization techniques rely on derivatives to adjust models for better accuracy. Derivative in linguistics. In linguistics, a derivative is a word formed from another word, often by adding prefixes or suffixes. This process helps create new words while preserving their root meanings. Example: prefixes and suffixes. The word happy becomes unhappy when un is added. Similarly, nation becomes national with ial. This process is derivational morphology, a fundamental part of language evolution. Example: multiple derivations. Act, action, active, reactivation. Words evolve through derivation, showing how language constantly grows. Many scientific and technical terms originate from derivatives. Language learning helps in understanding word structures and expanding vocabulary. Computational linguistics, used in natural language processing (NLP) to analyze text. Etymology studies helps trace the origin of words and their transformations over time. Derivative in chemistry. A chemical derivative is a compound formed from another compound through a chemical reaction. Chemists use derivatives to modify substances for better functionality, stability, or effectiveness. Example: aspirin from salicylic acid. Aspirin is a derivative of salicylic acid, modified to be safer and more effective. This chemical alteration reduces stomach irritation while maintaining its pain-relieving properties. Example: soaps from fatty acids. Soap is a derivative of fatty acids. Fats react with an alkali to produce soap and glycerin. This process, called saponification, is essential in the cosmetic and cleaning industries. Pharmaceuticals. Many drugs are derivatives of natural compounds, improving potency and reducing side effects. Food industry. Derivatives like artificial sweeteners and preservatives help enhance food quality. Materials science. Derivatives of polymers are used in plastics, textiles, and coatings. Derivative in finance. A financial derivative is a contract whose value depends on an underlying asset, like stocks, bonds, or commodities. Derivatives help investors hedge risks, speculate on price movements, and enhance investment strategies. Types of financial derivatives. Futures contracts, agreements to buy or sell an asset at a predetermined price in the future. Options, Contracts that give the right, but not the obligation, to buy or sell assets at a set price. Swaps. Agreements between two parties to exchange financial obligations. Forwards. Customized contracts between two parties to buy or sell an asset in the future. Example, futures contracts. A wheat farmer locks in a price by signing a futures contract to sell the crop at a fixed price later, protecting against market fluctuations. This ensures financial stability despite price volatility. Example, stock options. Investors use stock options to hedge against losses or speculate on price changes, similar to an insurance policy for investments. This helps companies and traders manage risk effectively. Insurance. Many policies are structured using financial derivatives. Foreign exchange market. Currency derivatives help businesses manage risks from exchange rate fluctuations. Cryptocurrency trading. Derivatives play a significant role in Bitcoin and Ethereum price speculations. Conclusion. Derivatives in mathematics measure change. In linguistics, form new words. In chemistry, modify compounds. And in finance, help manage risk. Understanding derivatives is useful in daily life, whether driving, writing, developing medicines, or investing. They are a crucial part of modern science, business, and communication. Mastering derivatives can provide deeper insights into various fields, from solving complex equations to making informed financial decisions. Their impact is vast and essential for progress in multiple domains. Like, subscribe, and comment on which derivative meaning was most surprising. More educational content is on the way.